Let us explore the graphical user interface of ExpEYES. Here it is shown. Left side you find an oscilloscope screen, that means a graph with time on x-axis and voltage on y-axis, and it is actually a 4-channel oscilloscope. Now the first channel A1 is displayed, and you can also enable the other channels. All 4 channels can be enabled. We'll come back to this later. So now let us have a look at the control and monitor widgets on the right side. Say here you see A1. If you enable this check button, it will show the voltage, DC voltage present at A1. At the moment nothing is connected to A1. So let us go and make some connection to A1. Say we connect A1 to say PV1, and now we come here and set PV1 to say 1 volt, and you can see here this is 1 volt, and it will vanish if you remove the wire. See, I have just removed the wire. Similarly, you can connect this to say A2 or A3, and say now A2 is having 1 volt, and I can change this say to 2 volts, right? Similarly you can use A3 as well. Now there is say resistance connected to the sen input, the sensor input. It says it is less than 100 ohm or greater than 100k. That means it is just open or short. So let us connect a resistor. So let us take a resistor and connect it from ground to sen. So we make a connection there, and when you come back we will see it is displaying the value of that resistor connected. So next thing is measuring the capacitance. You click here, so you will find a fraction of a picofarad, that is only the stray capacitance there. So we have to connect a capacitor to make a proper measurement. So let us say we will connect a capacitor between say in1 and ground, then come back to GUI and measure it. So it says there is a 22 microfarad capacitor. So the next thing is to measure a frequency. How do we get a frequency to measure into? So into requires a digital signal. So what we need is a square wave. So let us connect the square wave generator SQ1 to say A1 first to view that. Here there is nothing here, so we'll just say put some value here, and now the voltage range should be changed to 8 volt because it is more than 4 volts, and change the trigger level so that there is a stable signal. Now you see here, if you move the cursor, it shows the time and the voltage. Here channel 1 I1. See, if I keep the cursor, it shows. So here the voltage is 4.95, here the voltage is 0, right? So now this signal we want to measure the frequency. We already know the frequency is say 1524 Hertz. And one more thing, you can change the duty cycle. Now it is equal, right? 50%. So I can make this say 30%, right? So now what we do is we want to connect this signal to into also, so that we can measure the frequency. So we'll take a piece of wire and connect this signal to into as well. So we have a connection made here. So now you come back here, try to measure the frequency. So it measures the frequency as well as the duty cycle, right? So whatever you set, you get it back. But if you remove that piece of wire and then try to measure, it will say there is no signal. So it is actually measuring the external signal. Doesn't matter it comes from where. So next thing is to control the digital output. So to see that, we should connect the digital output to A1. So let us connect, say we need to connect say A1 to OD1 like this, and come back here. You see that A1 is 0 volts, but now if you enable OD1, see it went to near to 5 volt, right? That is your USB supply voltage. So if you can just change this, in the same way you can enable the constant current source as well, but that we need not see now. So the next thing is our waveform generator. So let us make a connection from this waveform generator to A1, then only we can see what is happening. So the WG is connected to A1 now. We'll go back and we see already here it is displaying, but we can go and change the frequency now. Say make it say 2000, and now it is displayed on channel 1 A1. Since it is only a 3 volt signal, a 4 volt full scale is good enough. Now you can enable the analysis so that you can get the frequency as well as the peak voltage information, right? So WG, what are the other things possible? So let us change the frequency to say very low, 200 Hertz. 200 Hertz, then you have to change the time base. If you want to see say one full cycle, you have to put it at say 5 millisecond, right? 5 millisecond is 200 Hertz, right? Because in 1 second you have how many cycles actually. Say 200 cycles for per 1000 millisecond, that means one cycle is 5 millisecond. So now you can go and change the shape of this to say triangular wave, or you can go and change the amplitude to say 1 volt or even 80 millivolt. But when you make it 8 millivolt, there is no point in seeing it in the 4 volts. You should go and see it in the 0.5 volt. But when you go back to your 3 volt, this is out of range, so you should choose an appropriate voltage range. But it gives one more option, say a square wave option, but if you choose that option, the waveform vanished. But there is a message output change from WG to square 2. So what we have to do is, it cannot generate a square wave on this, so you just shifted it to SQ2, and again see it says voltage is clipped, so we have to change the range to 8 volt, right? So now if you come back again, make it sine, go back to WG, so we see that signal has vanished. So what we have to do is, go and change the connection back to WG, right? So it is back. Now we also have the PV1. We have seen already how to use it, and PV2 is identical. So now let us see how to use the multiple channels. Suppose say A2 we enable, there is nothing connected to it, so it is always at 0 volt. So let us connect A2 to another signal. So let us take this say A2 and connect it to the SQ1. So now you see there are two signals simultaneously, and we again have to make this A2 signal, right? So you can change this frequency now. This is a lower frequency, right? Or you can just increase it. So two waveforms you are seeing simultaneously, and one is stable, other is not stable, because these two are not having any timing correlation. But you can choose the trigger source A2. So now this has become stable, the other one is not stable. That is because these two are not having any correlation in time. So now A3 also you can see simultaneously if you enable this here, and you can connect some other signal to A3. For example, say let us shift the sine wave to A3, right? And the last channel is the microphone. So let us disable these things. And how do we see the microphone output? For that, what we have to do is we have to connect the microphone first. So microphone need to be connected, and here we have the condenser mic, so that should be connected between, say, microphone input and ground. So we have the microphone here, and we can blow some air into that after seeing this channel here. So if you blow some air into that, it shows the signal. Or you can also give some other audio signal and measure its frequency. And now the time base we already explained. I mean, if you change the time base, what will happen? Like suppose say connect the sine wave again back to here, and time base decides the size of the x-axis. So if I want to see more cycles, I change this timing. And then the other one is the trigger level. So let us have a closer look at the trigger level. So here this is starting at 0, but if I change the trigger level, so it changes the starting point. So that means the trigger level decides where the voltage at 0 time. So that you can control using the trigger level, and you can choose the trigger source also. See, with A2 it will not be stable because there is no signal on A2. You have to trigger on this one. And here you can save these traces to a file. So you give a file name, say scope dot dat or txt. It is a plain text file, so you can give txt as well, and it saves to a file. And another option is to show the Fourier transform. That means this is a pure sine wave. So if you do a Fourier transform, say it will look like this, and it is a single frequency. There is no harmonics at all in this. It's a good sine wave. And another option here is the crosshair. So if you move here with crosshair, you can see the crosshair. It's not always required. Another option is, like suppose you have both A1 and A2, you can take a difference A1 and A2. So difference is shown here, difference signal. And freeze means it just stops measuring and just keeps the existing value. And you also notice here there is a enable pop-up help window. If you click that, there is a pop-up help. And the next thing is now about the menus. So here you see the first menu is device menu, that the reconnect. Only if some error occurs you need to use this. Otherwise here, now suppose say you go and choose this menu, voltage measurement. So immediately the pop-up window says how to make the connections and what to be done. So here a lot of items here in this. First, suppose say you want to make a lemon cell and measure it. So this shows how to make the connections and what need to be done. Then there are other menus like the electronics menu. You have oscilloscope, half-wave rectifier, and many other things. And in the electrical, say plotting IV curve, XY plotting, and study of RC circuits, LCR elements, and electromagnetic induction, everything. And then you have some sound experiments, some mechanics experiments, and other miscellaneous things. And we also have some small Python programs you can execute. That is basically to know about the internals of this box. Say suppose you say choose this one, so it shows some Python program here, and I can say execute that code. So it should show the output of that code. That will look something like this. Suppose if I change this code to 100 points and execute it again, I get the output like this. But if I make it say 1000 points, or say make it 500 and make this 50, run it, so I get this output. So this is basically to give you some idea how to program this box using Python. For example, if you want to make an arbitrary waveform, say here you give an equation and you can convert you can generate a waveform of that kind. So let us see what is the output. See, it will look like this, the output of this program. And if you connect any other oscilloscope to WG, this is the kind of signal it will be generating. So this more or less gives some idea about the different programs, you know, they like experiments which you can do. Suppose, say, to give some example, let us choose half wave rectifier. So it says if you want to study a half wave rectifier, what you have to do is take the waveform generator, monitor is OA1, and through a PN junction connect it to A2. So we can do that now. Say we just enable A2, but there is a square wave there, so we have to go back and make a proper connection. Here what we have to do is we have to just connect a PN junction between A1 and A2, right? So we have connected a PN junction diode like that, and if you see here, this is the output. That is what is expected, right? And that is how you perform experiments using this GUI.